To determine if a cable installed in a sectionalizing switch has been bent too tightly, you must first reference the applicable codes and standards. IEEE 399, which is the standard for enclosed switches, and the National Electrical Code, or NEC, provide guidance on this topic. Specifically, IEEE 399 includes a table with minimum allowable bending radii for various conductor sizes and types. You can access IEEE 399 to find this information. The NEC in Section 305.12 specifies a minimum bending radius for underground cables, stating it as 12 inches multiplied by the outside diameter of the cable. You can access the NEC for further details. To perform the calculation, firstly determine the cable's outside diameter, often referred to as OD. This can be found on the cable manufacturer's specifications or measured directly using appropriate tools. Secondly, calculate the minimum allowable bending radius. Use the formula 12 inches multiplied by the OD as specified in the NEC. For example, if you have a cable with an outside diameter of 1.25 inches, the minimum bending radius would be 12 inches times 1.25 inches, which equals 15 inches. When evaluating the cable installation, if the cable in the sectionalizing switch has been bent with a radius that is less than the calculated minimum, it should be considered too tightly bent. Bending the cable too tightly can compromise the integrity of the insulation and potentially lead to safety issues such as electrical faults or premature cable failure. Several additional considerations should also be taken into account. The type of cable, whether it is copper or aluminum, and its construction, for example, stranded or solid, can affect the minimum bending radius. Different materials and constructions have varying degrees of flexibility, so the bending radius must be adjusted accordingly. The temperature of the cable can also affect its flexibility and the minimum bending radius. Cables become more pliable at higher temperatures and more rigid at lower temperatures, so temperature considerations are important. It is always recommended to consult with the manufacturer's specifications for specific cable bending guidelines. Manufacturers often provide detailed information about their products, including recommended bending radii, temperature ratings, and other relevant data. By following these steps and considerations, you can accurately determine if a cable has been bent too tightly and ensure the safety and reliability of the electrical system. Adhering to the minimum bending radius helps to prevent damage to the cable insulation and conductors, reducing the risk of electrical hazards. When evaluating cable bending, it is important to consider the long-term performance and reliability of the installation. Over time, cables that are bent too tightly can experience increased stress and fatigue, leading to premature failure. This can result in costly repairs and downtime, as well as potential safety hazards. Therefore, it is essential to prioritize proper cable bending practices to ensure the longevity and safety of the electrical system. In addition to following the NEC and IEEE standards, it is also important to consider any local electrical codes or regulations that may apply to the installation. Local codes may have specific requirements or restrictions related to cable bending, so it is essential to be aware of these requirements and comply with them. Furthermore, it is important to use appropriate tools and techniques when bending cables to avoid damaging the insulation or conductors. Using specialized cable bending tools can help to ensure that the cable is bent smoothly and evenly without creating any sharp bends or kinks. It is also important to avoid overbending the cable, as this can also damage the insulation and conductors. In some cases, it may be necessary to use cable supports or trays to provide additional support and protection for the cables. Cable supports can help to prevent the cables from sagging or bending excessively, which can reduce the risk of damage and improve the overall appearance of the installation. When selecting cable supports, it is important to choose supports that are appropriate for the size and type of cable being used. It is also important to ensure that the cable supports are properly installed and secured to prevent them from shifting or falling down. Overall, proper cable bending practices are essential for ensuring the safety, reliability, and longevity of electrical systems. By following the recommendations outlined in the NEC, IEEE standards, and manufacturers' specifications, you can help to prevent damage to cables and reduce the risk of electrical hazards. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations. These guidelines are designed to ensure the safety of people and property. The NEC is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. Compliance with the NEC is essential for all electrical installations, and it is important to stay up to date with the latest edition of the code. The Institute of Electrical and Electronics Engineers, or IEEE, is a professional organization that develops standards for electrical and electronic engineering. IEEE standards cover a wide range of topics, including cable bending, grounding, and power quality. IEEE standards are widely recognized and respected in the electrical industry, and they are often referenced in the NEC and other codes and regulations. When selecting cables for an electrical installation, it is important to choose cables that are appropriate for the application. Cables are available in a variety of sizes, types, and materials, and it is important to select a cable that is capable of carrying the required current and withstanding the environmental conditions. Cable manufacturers provide detailed specifications for their products, including information on the cable's ampacity, voltage rating, and temperature rating. It is important to review these specifications carefully to ensure that the cable is suitable for the intended application. Cable installation is a critical aspect of any electrical project. Proper cable installation techniques are essential for ensuring the safety and reliability of the electrical system. It is important to follow the manufacturer's instructions and the recommendations outlined in the NEC when installing cables. Cable terminations are another important consideration. Cable terminations must be properly installed to ensure a secure and reliable connection. Poorly installed cable terminations can lead to overheating, arcing, and other electrical hazards. It is important to use appropriate tools and techniques when terminating cables and to follow the manufacturer's instructions carefully. Electrical safety is paramount in any electrical installation. It is important to take all necessary precautions to prevent electrical shocks and other hazards. Always de-energize the circuit before working on electrical equipment, and use appropriate personal protective equipment such as gloves and safety glasses. If you are not qualified to perform electrical work, it is important to hire a licensed electrician. In summary, evaluating cable bending involves understanding and applying relevant standards, performing calculations based on cable dimensions, and considering environmental and material factors. By adhering to these guidelines and consulting manufacturer specifications, you can ensure cable integrity and prevent potential safety hazards in electrical installations. Remember that the outside diameter is a critical factor and should be accurately determined. The type of insulation also plays a role. Cables with thicker or more rigid insulation may require a larger bending radius to prevent damage. The location of the cable installation can also impact the bending radius requirements. Cables installed in confined spaces or areas with limited access may be more susceptible to damage if bent too tightly. In these situations, it may be necessary to use a larger bending radius or to consider alternative cable routing options. Regular inspections of cable installations can help to identify potential problems before they become serious. Look for signs of damage to the cable insulation, such as cracks, cuts, or abrasions. Also, check for signs of overheating, such as discoloration or melting of the cable insulation. If you find any signs of damage or overheating, it is important to take corrective action immediately. This may involve replacing the damaged cable or making adjustments to the cable routing or support system. The use of cable management systems can also help to improve the overall safety and reliability of electrical installations. Cable management systems such as cable trays, cable ladders, and cable ties can help to organize and support cables, preventing them from becoming tangled or damaged. These systems can also make it easier to inspect and maintain cables. When working with electrical cables, it is important to be aware of the potential hazards involved. Electrical cables can carry high voltages and currents, and contact with live cables can result in serious injury or death. Always to energize the circuit before working on electrical cables and use appropriate personal protective equipment. It is also important to follow safe work practices, such as avoiding contact with water and wearing rubber-soled shoes. In addition to the NEC and IEEE standards, there are other resources available to help you learn more about cable bending and electrical safety. These resources include textbooks, training courses, and online tutorials. Taking advantage of these resources can help you to improve your knowledge and skills in this area. Remember that electrical work can be dangerous, and it is important to be properly trained and qualified before attempting to perform any electrical work. If you are not sure how to do something safely, it is best to consult with a licensed electrician. By following these guidelines and taking appropriate precautions, you can help to ensure the safety and reliability of electrical installations. The purpose of the minimum bending radius is to prevent damage to the conductors and insulation within the cable. When a cable is bent too sharply, the conductors can become stressed and may eventually break. The insulation can also become damaged, which can lead to short circuits and other electrical hazards. By adhering to the minimum bending radius, you can help to prevent these problems and ensure the long-term reliability of the electrical system. There are several factors that can affect the minimum bending radius of a cable. These factors include the size of the cable, the type of insulation, the temperature of the cable, and the presence of any other objects or structures that may be in the way. It is important to consider all of these factors when determining the appropriate bending radius for a cable. The NEC provides specific requirements for the minimum bending radius of various types of cables. These requirements are based on the size and type of cable, as well as the voltage and current that the cable is designed to carry. It is important to consult the NEC to determine the specific bending radius requirements for the cables that you are using. In addition to the NEC, there are other standards and guidelines that may provide information on cable bending. These standards and guidelines may be developed by organizations such as the IEEE, the National Electrical Manufacturers Association, or the cable manufacturers themselves. It is important to be aware of these other resources and to consult them as needed. Cable bending is an important aspect of electrical safety. By following the appropriate guidelines and taking the necessary precautions, you can help to prevent damage to cables and ensure the safety of electrical systems. Always double-check your calculations and measurements before bending any cables. It is better to err on the side of caution and use a larger bending radius than necessary. If you are unsure about the appropriate bending radius for a particular cable, consult with a licensed electrician or other qualified professional. Cable bending is a critical skill for anyone working with electrical systems. By mastering this skill, you can help to ensure the safety and reliability of electrical installations. The formula 12 inches times OD is a simplified guideline. Always refer to the manufacturer's datasheet for precise bending radius specifications, as variations exist even within similar cable types. If the cable is subjected to repeated bending, such as in a movable application, the bending radius may need to be increased to further reduce stress on the conductors and insulation. When installing cables in cold environments, the bending radius should be increased because the cable becomes less flexible and more prone to cracking. The NEC provides tables that specify the allowable ampacity of conductors based on their size, insulation type, and installation conditions. These tables can be used to select the appropriate size of cable for a particular application. The NEC also provides requirements for the overcurrent protection of electrical circuits. Overcurrent protection devices, such as fuses and circuit breakers, are designed to protect the wiring and equipment from damage caused by excessive current flow. It is important to select the appropriate overcurrent protection device for each circuit to ensure that the wiring and equipment are adequately protected. Grounding is an essential aspect of electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip the overcurrent protection device and prevent electrical shock. The NEC provides detailed requirements for grounding electrical systems. Surge protection is another important consideration for electrical safety. Surge protection devices are designed to protect electrical equipment from damage caused by voltage surges, such as those caused by lightning strikes. Surge protection devices should be installed at the service entrance and at any sensitive electronic equipment. Electrical inspections are an important part of ensuring the safety of electrical systems. Electrical inspections are typically performed by qualified electrical inspectors who are familiar with the NEC and other applicable codes and standards. Electrical inspections can help to identify potential hazards and ensure that the electrical system is installed and maintained in accordance with the applicable codes and standards. The importance of documentation cannot be overstated. Keep records of cable specifications, bending radius calculations, and any deviations from standard practices. This documentation can be valuable for future maintenance and troubleshooting. In summary, determining the correct cable bending radius is not merely a matter of following a simple formula. It requires a comprehensive understanding of electrical codes, cable characteristics, and environmental conditions. By paying close attention to these factors, you can ensure the safety and reliability of electrical installations.